Hello, welcome back to Math Addicts. Last time, we unlocked the most basic and fundamental skills of mathematics, the Riemann hypothesis and its relation to the theory of relativity. Though some of our audience found it too easy to watch, and in turn, we got less views on that video. So let's move on to something so difficult it could reveal the secrets of the universe. The limits of a function. No. Please don't exit the video yet. I know this looks hard and something that even people with PhDs shouldn't even touch on, but I firmly believe in the person who is gonna teach us today. He did not graduate Harvard. Harvard graduated from him. He did not graduate college because no college passed his entrance test. He doesn't have a degree because he prefers radiance. It's not other than myself. So hi, my name is Josh Landicho. I am here to teach you limits of a function, specifically some limits theorems. But don't worry, I know you have your limits, but that won't stop you from learning limits, because I will make the most complicated concepts turn into the easiest concepts you will ever learn about. So without further ado, these are the three hardest limit theorems that we will tackle. First, the substitution law. Second, the addition theorem, and lastly, the multiplication theorem. So now I will explain the first theorem we're about to tackle, the substitution law. As hard as it sounds, it is pretty basic once I teach it to you. Basically, substitution law states that the limit of x as x approaches to c is equal to c. To understand quickly, let's take a look at these examples. The limit of x to the power of 4 as x approaches 4, and the limit of 4x as x approaches to c. We solve it like this. Basically, we substitute c to x and we can solve the limit. So as you can see in here, we substitute this is c, this is this part, and we substitute the x to the c. So as you can see here, the x turned into the 4. And then this is 4 to the power of 4, which is 256. And then limit of 4x, and we substitute this is the c, we substitute this, so 4 is this is 4 times 6, and then 4 times 6 is 24. So that's basically what the substitution law states, and now we will move on to the next. Now that's it for substitution law. Next is the addition theorem. Basically, the addition theorem states that the limit of a sum of functions is the sum of the limits of the individual functions. To quickly understand, let's take a look at these more examples. So let's say these are the three functions f, g, and h. Alright, so we have our three limits here, this, and this. So limit of f of x as x approaches to 2, limit is equal to 9x, limit of g of x as x approaches to 7 is equal to 10 minus x plus 2, and the limit of g of x as x approaches to 1 is x to the power of 10. So let's quickly try these examples. So now applying the substitution law, we could solve this like this. So first, let's go to the f of x. F of x, this is 9x, and then we substitute again. We substitute the x with the c. So this is the c, so this is 2, and substitute it to the x, so 9 times 2, which is 18. That's pretty basic. So next, limit of g of x, we substitute 7 to the x, so that is 10 minus 7 plus 2. 10 minus 7 is 3, and 3 plus 2 is 5. So we get this final answer. And then next is, this is limit of h of x. Limit of h of x is x to the 10th power, and we substitute the x with the c, which is the 1. This is the c, so 1 to the 10th power is still 1. So basically, we gather these examples and we gather these answers, and we would arrive with this. Now we know that f of x is 18, g of x is 5, and h of x is equal to 1. So let's go back to the main equation. If we substitute this to the main problem, f of x plus g of x plus h of x, we get 18 plus 5 plus 1. So 18 plus 5 plus 1, which is equal to 24. Now, the multiplication theorem is very identical to the addition theorem. We also basically solve each function first. Before we proceed, examine these examples. So we have 8. This is the main problem. A of x, the limit of a of x times z of x. So we have a of x and z of x here. The limit of a of x as x approaches to 3 is equal to 4x plus 3, and the limit of z of x as x approaches to 5 is equal to 3x times 4. So again, as we have done from the past equations, let us first solve the individual functions. So we can see here, we substitute again. So 4x, we substitute the x with the c, which is 3. 4 times 3 is 12 plus 3, 15. So again, from the z of x now, 3x, which is we substitute the x with the 5, which is the c, and then 3 times 5 is 15, 15 times 4 is 60. So now we're not done yet, though we have both of these answers. We're not done yet because we will proceed to the main equation. The main equation is a of x times z of x. We have a of x, which is 15. We have z of x, which is 60. So we'll multiply both of those and we substitute. So 15 times 60 is equals to 900. So now that's it for this video. I hope you all learned something and can now proudly tell your peers that you learned something so difficult even some physicists cannot comprehend it. And because of that, I hope you subscribe. Stay tuned for our next video, which we will tackle the Fibonacci sequence of the black hole and how it shows us the existence of the antimatter. Bye.